When you're completing word problems, and now this is page 41, you want to make sure you're reading it correctly. When you see a word problem like this, usually the equations that you're going to need are in the problem itself. So it says you're helping plan a banquet. You need to rent tables that seat 180 people. Small tables seat 4 people, and large tables seat 6 people. It can be modeled. Well, hey, right there is your equation. And it tells you that X is small tables and that your Y is large tables. So it kind of tells you your axes right there. You can immediately go ahead and label your axes because it says X are small tables, right? So it's number of small tables. Meanwhile, your Y, you know, is number of large tables. It says find the intercepts. Well, we've done that before, right? We found intercepts before. So we're going to take 4x plus 6y equals 180. We can find the x intercept by substituting in 0, right, for y, or we use a cover-up method. If we use a cover-up method, we know that 4x equals 180. So 4x equals 180. X is going to be 45. So this coordinate point is 45, 0. Guess what? That is my x-intercept. Let's find our y-intercept. Do the opposite, right? If I use a cover-up method, I'm going to cover up x, or I can put it in for 0. Either way, I end up with 6y equals 180. So y is equal to 30. So my coordinate point is 0, 30. And I can highlight those just so that I have it. Okay, let's continue reading the problem. It says, find the intercepts of the graph of the equation, then graph the equation. Give 4 possibilities for the number of each size table you rent. Right now we have 2 possibilities, right? We can have 45 small tables and 0 large tables. Or we can have 0 small tables and 30 large tables to seat these 180 people. Now, before we actually go ahead and graph it, we need to give ourselves numbers on these axes. I'm going to count by 5s. I think it'll fit. So 45, I stopped at 45 because my x-intercept, remember, is 45. This is the highest I need to go, right? I have that point right here. And then I need my y's. I'm going to still count by 5s. And I guess I could have stopped at 30, that's fine. Because the y-intercept is 30, so go ahead and plot 30. Great, I have my 2 points, and then I'm going to want to draw a straight line between the 2 points. You're going to need a ruler for this, and you want to try and get as straight as possible here. Because we need to find 2 other points, right? So we start looking like, hey, is there anywhere it fits perfectly? Like anywhere that you see on this line and the grid lines, right? These grid lines in the back hit perfectly. Okay, well, actually right here and right here. So I have 2 points right there. I'm going to highlight them in blue just so you can see them right here and right here. Those are 2 additional points I can have. So I have 30, 10, and I have 15, 20. Now, if you're not sure if you read them right or if you're not sure it's going to work, well, you can substitute this into my equation, right? My equation is 4x plus 6y equals 180. It's like doing a check. Well, I can put 30 into x and 10 into y and see if that calculation actually gives me 180. So I get 4 times 30 plus 6 times 10. And let's see if it equals 180. This is 120 plus 60, which does give me 180. Hey, guess what? It balances out. That means this is a solution. We can have 30 small tables, 10 large tables, and then that will fit the 180 people. So you want to do that again for the next one, right? Check it. See if that's actually a solution to this problem. So we have 4 times 15 plus 6 times 20. Does it equal, that's why we have the question mark there, 180, right? We have 60 plus 120. That does give me 180. That does balance out, meaning this is another solution. So this yellow we just answered right here. We just answered for how many size tables we can rent. Then it asks you, what do the intercepts represent? Well, those represent the maximum number of small or large tables, right? That's what our intercepts represent. So it's the maximum number of small or large tables. Then you want to write our domain and range. Yes, this has not left the building, right? You can write the domain and range. Our x, we want to look at our x-axis here. So our x, which I'm going to write in blue just so we say coordinated, our domain is our x. Well, it has to be less than 45 tables, right? We can have maximum 45 tables, and we want to have 0 tables or more. Then for our range, what is the smallest amount of tables we can have? Well, 0. The largest number of tables we can have for the large tables, right? Those seat 6 people, whereas the small tables seat 4 people. Maximum we can have is 30. If you notice, these numbers came straight from the intercept, right? 45 was the largest amount you can get in small tables. 30 was the largest amount you can get in the large tables. Go ahead and try problem number 2. You can pause the video here as I'm going to move on to the next page on page 42. Now this one's a little bit different because now we have 2 equations, right? It says my gym charges a one-time membership fee of $100 and $20 per month. Instead of having to sit there and write this, we actually have our equation given to us. Then it says I spent on gym time membership, and M is the number of months that you've belonged to the gym. My husband gets charged a one-time membership of $60 initially, and then gets charged $20 a month. Again, this equation is given to you. So we're going to plot both equations. Now, I might count here 1, 2, 3, 4, 5, 6, right? So on and so forth, because this is a number of months. The reason we know it's a number of months is because it says charges 20 per month, $20 a month, number of months, right? It says our slope is, or my M, which usually is y equals mx plus b, right? See that M over here took the place of the x. So that's my x-axis. And then my total cost is going to be here because that's C, right? C is a total cost. And it says it up here as well. C is the total cost. And I'm going to number those. This is going to be numbered oddly because I'm going to put a break. That's what that lightning bolt means. I'm going to start at 50 and count by tens. That break only works when you're going to take a large jump in your counting so that it makes it easier for you when you go to graph this. Okay, in blue, I'm going to have that first equation. So it says 100, so I have a y-intercept of 100, and I'm going to go up 20 to the right 1, right, because it's a slope of 20. Now be careful here, because if I go up, I'm not counting 20 boxes. I'm just counting 1 box, 2 boxes, because each up is 10, right? That's what we were counting by tens. So be careful here. And then I'm going to go 1 to the right, because again, we're counting by ones here. So be careful when you do something like that, when you're skipping numbers, because then when you go to plot this, it still needs to make sense. And then I'm going to plot my green one, right? That one starts at 60. Again, goes up by 20. So 10, 20 over 1, 10, 20 over 1, so on and so forth. Now from the last lesson, we can say what kind of lines these are, right? They're parallel. They're never going to touch. You could probably figure out what the better deal is because blue, I'm paying more and my husband's paying less overall, right? So you can try and figure out, like in real life, what could be better, right? So here it says, what does the slope of the graph? Well, the slope we know is the cost per month. That's that $20 a month you're spending. Whereas the y-intercept is the initial fee I have to pay, right? If I read it from the graph, you'll see at 0 months, right, at the start, I'm going to pay $60 at this gym or $100 at this gym. I'd probably go for the 60 depending on those amenities. Try the one below this. It's very similar to how it's written. Pause the video because I'm going to go on to the last type of word problem that you'll see with these graphs, and that's on page 43. We have a red oak tree that grows at a rate of 2 feet per year. Right, so 2 feet per year. And you buy and plant 2 red oak trees, one that is 6 feet tall and one that is 8 feet tall. So one is 6 feet tall, one is 8 feet tall. These each can be represented by h equals 2t plus 6, right? The 6 is the initial height it started at, and then h equals 2t plus 8. This is the same thing as last time that we were doing the previous problem, right? You're going to go ahead and graph it. I'm going to reveal that graph in just a second. But take a look at the bottom. The bottom says use the graph to determine the difference in heights after 5 years, then 10 years. What do you notice about the difference in the heights? How can this be explained mathematically? So I'm going to go jump right to the answer because I want you to see how you would describe such a problem like this. So here's your graph. Highlighted in blue is an intersection at 5 years and 10 years. So they're always 2 feet difference because they grow at the same rate, the same slope, right? They're parallel lines. If you notice, at 5 years, the red one is at 16 feet, the other one's at 18 feet. And then in 10 years, it's 26 feet versus 28 feet, right? There's always 2 foot difference because since they grow at the same rate, they're always going to be 2 feet apart, right? There's always going to be a 2 foot height difference. Go ahead and try number 2, right? Sometimes it might be different when you have different slopes.